All right, so welcome to
Part 4.
the lecture series on Introduction to Computer Networks on the topic of transport and application layer. So we'll jump off to the point from where we left off. So understanding the overall operations and features which come with the transport layer, we'll now go into the application layer, which is the topmost layer in the TCP/IP model. So the application layer uh, for TCP combines the operations which are performed in the application, presentation, and session layer in the OSI model. The overall purpose of the application layer is basically to provide an effective interface um, between the application that is running on the host with the rest of the network stack. Such actions may include, but is essentially not limited to, uh, user authentication, which is basically an application layer duty with respect to the OSI model. It may also be required to perform the data format conversion. For example, if you are transferring an image, it's in the form of JPG or PNG. If you're transferring text, it's in ASCII code, etc. If uh, there are any form of encryption methods which are involved for the application, that is also a part of the duties to be performed in the application layer. And one additional thing which is interesting as well is the concept of sessions. So this is specific to the session layer in the OSI model. With respect to TCP IP model, we refer to it in the application layer as well. And the concept of session says that let's say if you are playing a video on YouTube and the video starts playing, and then you go ahead and click on the pause button. So the video pauses playing, and then you click again on the play button. The video starts playing. You can click on the bar to rewind or forward the video. So all of these are session oriented interactions for the application, and that implies um, when that particular session is starting, stopping, and the overall management for that application and the transfer of the data. So all of these features together is supported in the application layer. So if we try to motivate ourselves a little further, so let's say we have three applications running on a host. One of them is Skype. You have YouTube running on a browser window. And let's say you also have a torrent file downloader to download a file. So the Skype data, which is being transferred from the application into the network stack, um, is the data encrypted? Well, it's not encrypted if you try to consider the data that is being generated directly. Does the computer understand the message? Well, not exactly, because the Skype is generating the data based on images and a combination of images to convert it into a video, but your computer does not understand how to transfer this exact video through the network into another host. So that is when the presentation layer with respect to the OSI model comes into play. And again, it's a part of the application layer in the TCP/IP model. So what this layer does is that it basically encrypts and encodes that data that is being generated from Skype, and before it is sent on to the network stack in the transport layer. So this conversion and the application of encryption on the data is applied by the presentation layer. So if you look at multiple of these applications which are running on the same device, uh, the data that's being generated from Skype, YouTube, and the downloader, so all of these are converted into encoded and encrypted format by the presentation layer. However, we say that, for example, with Skype, you are, for example, calling a user, then you are terminating the call, then you are calling another user. The same thing with the YouTube example that we talked about. You are playing a video, you are stopping it, you are resuming it, you are rewinding it. So all of these are session-oriented actions. So these additional sessions which we consider during the process of the transmission is handled by the session layer. So the session layer establishes the user and application session for that specific application within the process of the transmission. So that kind of summarizes the overall um, ideas that we have discussed for all the layers. And if we go back to the slide which discusses all the layers, so we talked about the physical layer, which is responsible for the transmission of the actual electric bits over a given media. It could be wired or wireless. The OSI model has the physical layer. The TCP/IP model, the newer model, has the physical layer as well. The data link layer in both the OSI and the TCP, it handles the concept of MAC addressing and device-to-device communication. Network layer in both the TCP/IP and the OSI model, it is dealing with the routing of packets, the transmission of packets from end to end, that is from a host to another host over multiple networks through a network of networks and multiple devices. Next, the transport layer is more interested into the applications which are running on a given device. And the operating system handles a lot of the addressing with respect to the ports, which are allocated for the transport layer segments, and we can identify the source and destination application for a given transmission based on the port addresses. And finally, the application layer in the TCP/IP model and the session presentation and application layer in the OSI model deals with the overall conversion of data, the user authentication, the control of the session of a transmission for any application.